Hi, my name is Jessica Rader, and I am so honored to be the 2013 Warren County, New Jersey Teacher of the Year. I teach in a self-contained learning disabilities classroom in Warren Hills Regional Middle School in Washington, New Jersey. My students are hard-working 7th and 8th grade students with mild to moderate disabilities who function at around a 3rd grade level. In the following lesson, you will be able to see that my students will be able to verify the Pythagorean theorem using math manipulatives. This lesson falls under Common Core State Standard 8.G.B6, which states, explain a proof of the Pythagorean theorem and its converse. As with all of my lessons, I take student IEP goals, and I use those goals to not only have my students master the IEP goals, but also master the state standards at the 7th grade level. For example, in the following lesson, you will see that my students have a working knowledge of square root and exponents. Both square root and exponents are my students' IEP goals and the building blocks of the Pythagorean theorem. I truly believe that with the right teaching methods and modifications, all students can be proficient on state tests, as well as be college and career ready. So please join me for a great math lesson. Come on, let's go meet the kids. Good morning. Good morning.
Good morning.
Good morning.
Good morning.
Okay, what I'd like you guys to do is have a seat, and at your seat you're going to find some purple rectangles. On the other side of those rectangles, you are going to have a math problem, okay? The answers are either going to be 3, 4, or 5. So what you're going to do is you're going to flip it over, you're going to solve the problem. Then what I'd like you to do is stand up, and I'd like you to find the match to those. So all the 3s are going to find each other, all the 4s are going to find each other, and all the 5s are going to find each other, okay? So I would like 3s to sit here, I'd like all the 4s to sit here, and I'd like all the 5s to sit here. So flip that over now, okay? So solve your problem, okay? And what I'd like you to do is then stand up and find where you should be sitting. So you're either going to sit in the 3s, in the 4s, or in the 5s. You've got 30 seconds. Go. Okay. So let me see what you got here. Square root of 9. 3. 3 times 1 is 3, and 6 minus 3 is 3. Excellent. Over here, we have 2 times 2 is?
4.
2 to the second is?
4.
And the square root of 16?
4.
Very good. Over here, the square root of 25 is? What group are you in?
4.
Well, we'll try again. Let's look here. You have 10 minus 5. What do you have?
5.
So what group are you in?
5.
5s, very good. And 5 to the first? Very good, excellent. All right, guys, you're in the right groups. So here's what I'd like us to go over today. If you look at the board, the goal says today you will be able to verify the Pythagorean theorem, okay? We've talked a lot about the Pythagorean theorem in the last couple of weeks, okay? And I know that you are all very familiar with this kind of triangle. Can anybody raise their hand and tell me what this kind of triangle is? Russell, what's that triangle?
Right triangle.
Very good, a right triangle, excellent, okay? And so we're gonna be solving the Pythagorean theorem using the right triangle. Can anybody tell me what the first part of the Pythagorean theorem is, the first part of the formula? Michael.
A squared.
Excellent, a squared, okay? Just like some of you have squares, right? You have 2 to the second, or you have exponents at your seat, okay? After this, we have a squared. I'm going to give you the next part. It's a plus, okay? Then what's the second part?
B squared.
B squared is correct. Excellent. Okay? And then the next part is equal, okay? Equals what? Just C squared. Excellent. Okay. So now that we have this, and we've solved this many times, so we know how to do the Pythagorean theorem, but we don't know why it works. Okay? Somebody gave us this formula, and we know it works, but why does it work? Okay, and that's what we're going to show today. So I want you to look at this side of the triangle, and that side of the triangle is A equals 3. Okay? So if we would take A equals 3 and we'd plug it in down here, we'd say 3 squared, correct? What is 3 squared? What is 3 squared? Raise your hand, please. 3 to the second. You can use your calculator. You can use your calculator. JC? 9. Very good. Okay. So A squared is 9. We're gonna bring the plus down. How about B squared? Our B equals what? B equals what? Russell? 4. So if we're gonna square 4, so we have 4 squared, what would that be? Michael? 16. Excellent. Okay. So now we have 9 plus 16. And again, we can use our calculators. 9 plus 16 gives me what? Gives me what?
25.
Very good. 25. Excellent. Guys, I told you you knew this. Now, we have to figure out then 25. What do we have to do here with 25 to get what C equals? What do we have to do? Carissa?
So we have to do the check mark on this side.
Oh,
Here.
very good. And what's that check mark called? The square root. So we're going to take the square of 25. Ooh, I like seeing all these hands. Very nice. And the square root of 25, Justin, is
5.
5. Excellent. Okay. So then C will equal 5. Now, we're going to choose, I'm going to show you why this happens, okay? We're going to verify that this is true. We're going to verify that this is 5. We're going to prove it, okay? So here's what I'd like you to do. I'd like one person in the group to take that smaller triangle, the smaller right triangle, and I want everybody to participate. I don't want just one person to participate. So make sure that you have, everybody can reach the bowls of manipulatives that you have on your table, all the squares. So here's what I'd like you to do. We're going to create a square that comes off of this leg, okay? So I'd like you to put it where you can see the side A, side B, and the hypotenuse of side C, okay? And here's what I'd like you to do. Let me ask you a question. This is 3, correct? A is 3. If we're going to make a 3 square, let's think about it this way. We said 3 is squared, right? If I'm going to make a 3 square, a perfect square, now a perfect square has the same, all 4 sides are the same, correct? So if this side is 3, because we said A is 3, and let's just say we make a square, which you guys are also going to make. If this side is 3, then that's a pretty ugly square, but if this side is 3, what's this side? Raise your hand. What's this side? If this side is 3 and they're all the same, what's this side? Lauren? 3. Excellent. How about this side? Russell? 3. Okay. And how about this side then? Carissa? 3. Excellent. So if these are all 3, now how can I make this a 3 square? Think about arrays. Okay? And we said this is 9, right? So how can we make 9 blocks here that's arranged 3 by 3? What can we do? Michael?
You go 3 down,
Mm-hmm.
3 across.
Excellent. So what I would like you guys to do, very good, Michael. What I'd like you to do is in your groups, I'd like you to create with one color of these blocks. I would like you to create a 3-side, like Michael said, a 3 across and 3 down square off the side A. Okay, go ahead. Miss Solly, would you mind looking at this table, please? I'm going to go over here. Okay, so what I would like you guys to do, and let me see this correctly. Okay, so say we're looking at it like this. Which side is A? If we're looking at it, which side is A? Very good. So I want you to create a square. Maybe we use the blue, and you're going to create what Michael said, a 3 by 3 square. Okay, and you have to have...
So it's like 3 across and 3 down?
That's correct. But there has to be 9 squares there. Okay, so why don't you do one row and let Maria do another one.
And Heidi do
And
another?
very good, very, very good.
teachers take turns. Like,
Okay, that sounds really good. Keep going. Okay, I'm coming around. Okay, so the only thing that I'd like, and that's perfect. The one thing that I would like you to do though is make it so that it sticks to the side of the triangle. Okay? So, right, so then the next one then you're gonna have to, because we're gonna do the side B, you're gonna have to make it come down here. So any way you wanna do it is fine. Okay? So you see though that this, because this is 3 down, you've made a 3 square here, right? Okay? And how many is there?
9.
9, very good. Okay. Very nice, excellent. Now remember, we're gonna do 1 per group, so we're gonna be working on that triangle, okay? Excellent, yes sir.
If you make a triangle, a square here that goes 3 across and 3 down, what if you make a square here
Well, you're already going ahead, Russell, that's great. You're already thinking ahead. We made it on this side, and now we're going to do it on here, but it's not gonna be 3 squared, it's gonna be what? What do you think? Very good, very, very good. Why did you guess that? What does it say up there? B, the side B is what? 4. So it has to be 4 squared. Excellent, thinking ahead, I love it. I hope you enjoyed the lesson. Even though educating students is my #1 priority, I know that it is so important for teachers to be involved outside of the classroom in activities that improve student education. At the school level, I'm a member of the Faculty Advisory Committee. I have been fortunate enough to receive multiple grants, including the ExxonMobil grant, Target field trip grants, and the 2 Frederick L. Hip grants. I also spend my time here after school on a weekly basis to help students complete homework who need help. At a district level, I'm a member of the local professional development committee, and I've partnered recently with United Way to develop a peer mentoring program for the district. At the state level, I've won an Innovations in Special Education Award and have recently been accepted as the Children and Youth Education Coordinator for the New Jersey Council for Exceptional Children. I'm also very honored to be a New Jersey Teacher Advisory Panelist. Both of those positions have allowed me to analyze policies on education, provide feedback, and speak to my colleagues in New Jersey. I've also written an article for the NJEA Review that was published in January, and I'm so proud that my students were featured on 3 episodes of Classroom Close-Up. 1 almost won an Emmy. Every year, my students come to me in 7th grade, and they say to me, Miss Rader, I can't do this. I can't write an essay. I can't do a math problem. And I tell my students, yes, you can. You can do what you believe. So every year I take them to prove it to them. I take them on a 6-mile hike up a mountain. We walk over streams and through the forest, and we get up to the top, and I tell them, look what you can do. You've climbed 6 miles to the top of a mountain. So we go back down, and inevitably in a few weeks, one of my students again will say, Miss Rader, I just can't do this. I can't get to school on time. And that's when I pull out my pictures and I show them, look what you can do. You did. You made it to the top of the mountain. This is my passion, telling students and getting them to understand that they can do things that they believe they can't. I hope you've enjoyed my video, and thank you for watching.